So good evening, class. Here we are. We're going to look at nomenclature today. We're going to look at binary ionic compounds. One thing to make note about binary ionic compounds is the fact that we are looking at binary. Okay, so binary meaning two. Okay, so we're looking at two, I guess, two elements put together. And as we mentioned before, the idea that we're counting the uppercase letters. Okay, we're counting the uppercase letters. We're going to be looking at ionic. So with ionic, we are looking at the combination of a metal and a non-metal combination. Okay, so make sure that if you've got your periodic tables handy, it will really help a great deal with regards to knowing where some of these charges lie. Okay, so let's clear the screen. Okay, so as we mentioned, for anything that's ionic, we are combining a cation with an anion. Okay, so we are looking at here the cation. So the cations are the positively charged ions. So these are to the left of the aluminum ladder on the periodic table, and we've got the anions, which are the negatively charged ions on the non-metal side, which are to the right of the periodic table. Okay. So let's clear that. So when forming a compound, these are the three options. So an atom may give up an electron, right? So metals give up the electron, right? So we've got the, so pretty much give up. So metals are the ones that give up. Metals give up. The idea that an atom may gain an electron, these are the non-metals. Okay, and this combination here is what forms the ionic. And we're going to look at the ionic for now. We're going to leave this sharing of the electrons because this happens amongst the covalent. So the covalents are the ones that are going to be sharing their electrons. Okay, so let's clear that. Let's move on to the next slide. Oops. So we're not going to worry about the diatomics for now. We're going to move on just because this is more focused in our reaction types. Okay. One thing to make note when it comes to nomenclature of binary compounds is this ending here. Okay, so we've got the ending for these simple non-metals in the ionic bond. Okay, so in an ionic compound, you have the metal non-metal combination. The non-metal aspect, when naming it, will have this IDE ending. So that IDE ending, examples like sodium chloride, right? It's sodium and chlorine, but the ene from chlorine gets dropped to IDE. Okay, something like combining magnesium and bromine, so it become magnesium bromide. The bromine, the INE ending, that gets dropped for the IDE ending. Okay, so remember that typically with binary compounds will have that IDE ending. There are going to be a couple of exceptions, as we're going to see once we get into the polyatomics. Okay. So let's clear that. Let's move on. Oops. Okay, next slide here. So when we are naming, and this goes back to very first evening's class when we were kind of just doing a review of some of these simple nomenclature. I understand that we look for these charges. Okay, so these charges that you're going to see here as I have circled here, lithium has the +1, this sulfur has the -2. If you know your rules, okay, so if you know your rules for how metals lose their electrons, non-metals gain their electrons, you can figure out what these charges are. However, if you've got my periodic table, that's the one I'm using. I'm going to I'm going to have a link underneath also this video once I post it on my channel, which will give you access to that periodic table. But on my website, you'll have access to that periodic table right on the main page, and you'll have all those charges. So those charges, another way of referring to these charges is calling them an oxidation number. Okay, so the oxidation number of lithium is a +1. So when we are writing out the formulas, right, and we're doing our crossover rule, as we're going to see in a moment, that oxidation is what we will be using, that oxidation number, or the charge, as I'll refer to them. I don't really refer to them as oxidation numbers, but the technical term for these charges is the oxidation number. Okay, so let's clear that and move on. So here is the 5-step crossover rule that I outlined on the very, very first night. First step is to identify if we have a metal, non-metal. And I can't stress just how important that is. That is really what you are looking for. You're looking for this non-metal metal combination. Okay, because once you identify that, you will be able to figure out that you could use these steps. Okay, so you can't use these steps. Okay, you can't use this 5-step crossover rule if you don't have that metal non-metal combination. So once you have that metal non-metal combination, then you can go about doing these 5 steps. And as you practice these 5 steps, you could do some of the steps in your head, let's say, and not worry about doing it step 1, step 2, step 3, step 4. Okay, so remember that this 5-step crossover rule is something that I've kind of put together to help me or to help students really just kind of water down step by step. How do you get to the final formula? It's as simple as step 1, write the symbol. Step 2, write the charge. So that charge, that's that oxidation number that we were just talking about. Cross over the charges from top to bottom. Remove the charges, simplify your numbers. So the numbers that you've crossed over, bring them to lowest terms. That's what that simplifying means. Like if you have a +2 and a -4 crossing over, or +4 -2, they would get simplified further. And then remove the charge, and then remove any ones, right? Sometimes we'll get a 1 when we're simplifying, or maybe we might be crossing over a +1 or a -1 in our crossover, and understand that we never put 1s in our formulas. So we always will remove that 1. Okay, so let's move on. So naming binary ionic compounds, real simple, using the chemical symbols that we already know, and knowing that the name will have the IDE ending. So we name the metal at the beginning as is. Okay, magnesium. No changing of the name, nothing. Right? But the non-metal, right? Fluorine becomes fluoride. Chlorine becomes chloride. Oxygen becomes oxide. Be careful with things like phosphorus. Be careful with things like so be careful with phosphorus. Be careful with oxygen. Oxygen becomes oxide. Be careful with sulfur. Sulfur becomes sulfide. I think I said phosphorus. Phosphorus becomes phosphide. It doesn't become phosphoruside or sulfuride. Okay, so be careful with some of those other ones. Okay, so let's look at here. We're going to try to go through these rather quickly. Sodium chloride, identify metal, non-metal. Yes, we have the metal, non-metal. So now we can go through the 5-step crossover rule. So step 1, right, after we've identified metal, non-metal, right, we write the symbols. Okay, then we write the charges after so these are the oxidation numbers. And if you look at the steps that we're going to do next, okay, understand that because we have the ones already, technically since they're both ones, really you can just get rid of those charges and put the whole formula together, NaCl. Okay, but we're going to walk through all these steps just so you see exactly how we get to it. Because this really, it's simple. It's this simple for all the binary ionic compounds, ionic, that is. And when we get into the polyatomics and including the acids, following these steps is exactly what you'll be doing to get to the final answer. Okay, so after the, so step 2, writing the charges. Next step, we're going to cross over from top to bottom. So that +1 goes to the bottom, the opposite side, so they cross over. Notice where they originally were here. Let's kind of animate that, right? They were there, and now they're there. Okay. Next step, remove the charges. Last step, we simplify, but there's nothing to simplify. But we can remove those ones, and then that formula put together becomes NaCl. I understand that not all of them are this easy. Okay, they're easy if both of the oxidation numbers, like the +1, -1, are the same. +2, -2 are the same. +3, -3 will work out the same. All right, those, 3 to 3 simplifies to 1 to 1. 2 to 2, 1 becomes 1 to 1. But some of them not so easy, as we'll see with this one here, magnesium fluoride. Okay, it's still simple. Okay, we follow the rule, identify metal, non-metal, and we have the metal, non-metal combination. So let's write the symbols. After we write the symbols, write the charges. Okay, after we write the charges, we cross over from top to bottom. Okay, remove the charge, simplify. Because there is a 1 already there, okay, because we have this 1, there's nothing to simplify. Okay, so that's a hint that if you have 1s, you don't need to simplify. And then the only thing is remove that 1. Okay, notice how the formula here, the 1 gets removed. So put this whole thing, put it all together so it actually looks like a full formula. And there we have it, MgF2. Okay, and that's the formula for magnesium fluoride. Okay, let's look at another one here where we're not going to have the 1 crossing over. So identify metal, non-metal. Okay, we have metal, non-metal. Notice it again, all of these IDE endings. Okay, so metal, non-metal. So we're going to write the symbols, calcium and nitrogen. We write the charges. So what's the charge? Again, you're going to need the periodic table. So the +2, -3, they're going to be crossed over. Okay. They're going to be crossed over. And then we're going to remove the charges, simplify. There's nothing to simplify. No number divides evenly in both of these coefficients. And there's no 1 to remove. So the formula is Ca3N2. And there is the chemical formula for calcium nitride. Okay. Here's a strontium oxide example, metal, non-metal. Okay, strontium, +2s, -2s. And as we said earlier on, because the 2 to 2 already will simplify to 1 to 1, just throw this whole formula together or go through all the steps, right? And we go, simplify to 1 to 1, and then finally, just like that, the formula becomes SRO. Okay. We're not going to go through the sample problems. The sample problems, you can all see that at the end. But in terms of naming, right? So we're going to go straight. Oops. I'm trying to get to my next. There we go. Last slide here. So I'm just going to go through the answers here. So one thing to make note of for the naming part, okay? When you're naming, always be careful. And we're going to see this. It really is simple for this first lesson, but eventually what we're going to see with the next lesson is all of these metals. Okay, so all the metals have one oxidation number, one, okay, whether it be a +1, a +2, +3, whatever it happens to be. However, if you look at the only one in this sample, in these set of sample problems that does not have an answer associated with it, okay, this one here is because if you look up iron on my periodic table, you will see that the oxidation number can either be Fe +2, Fe +3. Okay, so there's a special rule for these multivalent metals. But for all these other metals here that I have in these sample problems, all these metals are single valent metals, meaning there's one oxidation number for all of them. So when you name them, just name them normally, right? The metal as is. The non-metal part will have the IDE ending. Metal as is, the ending IDE. Notice here, all these endings, IDE. Okay, and if you look at the metal here in front, the metal is named as is. Okay, so let me stop sharing that, and let's get to a different, let's get to the next lesson here. So now we're going to look at the multivalent compounds. And so let's get the multivalent metals out. Okay. Any questions? If you you go to your picture, you should be able to. You'll see like 3 dots. You should be able to ask a question in those settings. So feel free to ask a question or even send it as a chat to me, and this way I can address any questions. Okay, so let's look at the multivalent metals here. So multivalent, as we mentioned moments ago, multivalent meaning you have more than one oxidation number. Okay, so we have more than one oxidation number. Iron, an example, lead, another one, vanadium, platinum. So these are multivalent metals. So these multivalent metals have a special way in which we name them, so we can address which charge or which oxidation number are we going to use. Okay, so groups 1 and 2 are simple. Okay, they only have one oxidation number, and a nice little hint here. Groups 1, they're all +1 oxidation numbers. Everything in group 2, +2 oxidation numbers. Okay, now from columns 3 to 12, many of them, not all of them. So think about that really flat part of the periodic table, that middle section. As I addressed, it's the D subshell when we were talking about electron configuration. So the D subshell being the transition metals. Those are the transition metals. Many of them are multivalent, meaning they'll have more than one charge. So these are the multivalents, and let's look at how we go about naming these. Okay, so there are 2 systems that we use. The most commonly used one is going to be the stock system. Okay, the stock system will use Roman numerals. Okay, so if you look at the examples here, iron, if we're using, so I wrote out iron, the +2, +3 moments ago with lesson 4.1. So here's iron 2. So iron 2 means that we're using the +2 charge. So that's with the Roman numeral. The iron 3 implies that we are using the +3 charge. So we actually will state with a Roman numeral which of the oxidation numbers we are to use with the metal. Remember, this is only with metals. Okay, and the transition metals, most of the transition metals in the middle. Understand that there are some transition metals that do not that are not multivalent. Okay, so scandium, for example. Okay, scandium, element number 21. It's in that transition section. It's in that D block, and in that D block, it has a +3 charge. So we would not use this method, the stock system method, to name it. The other one is the classic system. And the classic system is where we're using the Latin name, right? So if you look at some elements on the periodic table, we have something like iron here. How do we get iron from the letters Fe? Well, because scientists use the Latin name to give them their chemical symbols. Okay, so iron, the Fe, comes from the Latin word for ferrum. Okay, and we're going to see that right now. Let's get to the next one here. So here we have iron, copper, we have lead. So iron is ferrum. That's where they get the Fe. Copper, cuprum, and lead, plumbum. Usually my favorite to kind of do in a class to always get the giggles, but now doing this online, I don't hear any giggles, so it's not as funny. But anyhow, so notice where they got the PB. Okay, they took the first letter and they took the fifth letter. For copper, they took the first two letters, and for iron or for ferrum, they took also the first two letters. Okay, another one that you may see in a practice problem or is stannum. Okay, so stannum. If you look at the periodic table, what you want to do is look for the first letter and second letter, and you'll notice there is no ST. Then let's try the first and second letter, and you'll know there's no SA. But then you look for the first and the fourth letter, and you see, oh, wait a second, there's an SN. And when you look up SN on the periodic table, you will notice that SN is tin. So stannum is the Latin name for tin. Okay, so this UM ending, we never use it in naming. In fact, we drop this UM ending in favor of IC if we are using the higher of the two charges, or the higher of the two oxidation numbers, and we use OUS if we're using the lower charge. So take, for example, the higher charge for iron is Fe +3. Oops, my pencil is working here. There we go. Fe, and the lower charge is Fe +2. So if we're using this name, so ferrum would become ferric if we were using the +3. But if we were using the +2 iron, this UM, okay, this UM would be dropped in favor of OUS. And we'll see that here in a moment when we kind of we table all of them. Okay, so iron, ferrum. So this ferrum here, this UM gets dropped for OUS if we're using the lower charge, and this UM gets dropped in favor of IC if we are using the higher two charges. Cuprum will either be used as cuprous or cupric, and plumbum will be used as plumbus or plumbic, depending on, are we using the higher charge or are we using the lower of the two charges. Okay. Oops. Okay, so stock system. Stock system is the one most commonly used. On occasion, typically. I don't think we're going to be doing a nomenclature test. So in terms of your evaluations, I'm still discussing it with, I guess, my superiors to find out what's going on in terms of how evaluations are going to be how we're going to do it. I'm going to try to push that I'm ready to do evaluations online for this course. So this way we can kind of keep this course running throughout this this break that we're doing right now because of the coronavirus and our social distancing. And so I'm cool with trying to maintain this course and try to get you guys this credit online. So one of the things that I want you to know is I'm going to do what I can to try to push towards letting. That's one of the reasons why I want to document these videos so I can share exactly how we're running this course, how I'm running this course, and how I'm continuing to. I do want to keep our Monday, Wednesdays going the same way. So the 6:30 to whatever. So this is one of the things that I do want to want to let everyone know that what I'm going to do for us. Okay, so I'm going to try. Of course, the evaluations will be a little bit different because in terms of trying to keep, I guess, the integrity of the course. We'll try to figure out how we're going to go about doing the evaluations, but understand that I am working towards trying to modify this course so that we can still keep going this way. Okay, we're not going to be able to go in a class, but we're going to try to make it work. Okay, and know that I'm going to try to do what I can. So anyhow, let's going back here. The stock system, we're using the Roman numerals. Know your Roman numerals. Okay, here are your Roman numerals. One, we've got 1, we've got 2, we've got 3, we've got 4, we've got 5, and we've got 6. Okay, so understand what they are. Okay, so, and we will put these Roman numerals right after the metal. Okay, right after the metal. Okay, so we'll see what it's going to look like when we name it. Okay, that's so here we go. So here's some practice problems. The classic system name for this first one. Here's what we're going to get. Okay, so if we look at what we've got here, where did this 2 come from? This 2 came from iron. If we do reverse crossover, but be careful with that reverse crossover, and we'll see it in a moment, right? And this 3 also came from here, okay? Because what came from down here? There's no number here, so there were originally 1s that were removed, right? So those 1s go back. So we're using the +2 for this iron. We're using the +3 for the bottom iron. So if we're using the classic system name, and I'm going to be very specific, I'll either give you, I typically give the stock system name, and probably for the course in terms of our evaluations, what we're going to do is we're going to try to stick to stock system, make things a lot simpler. But I do want you guys to see, in case you might come across a sample problem or a homework question that actually has the classic system name, so you're not looking at it, oh my goodness, what's ferrous? What's ferric? Okay, and you're going to need to know those endings, because we're actually going to see these OUS endings and IC endings when naming acids, but we'll worry about that in a moment. Okay, so let's so notice here again, Roman numeral is right immediately following the metal. Okay, for some reason I see this in some in some student work where they'll put a Roman numeral after the non-metal, right? They'll put like a 1 because the charge for chlorine is -1. There's no need for that. This does not exist. We don't need anything for the non-metal. The non-metal will typically have the 1 charge. Okay, that we are going to be looking at. Okay, now there are some non-metals that will have are multivalent, but those multivalences are typically for Vesper, okay, for Vesper theory. Okay, so let's look at the next slide here. So steps again, crossover rule, 5-step crossover rule is as simple as we saw, right? But again, understand metal first, non-metal. We got to find that. Here's a hint that we have a metal, non-metal is this, that Roman numeral. That's the hint, because you will never see the Roman numeral as you know, you're not going to see it as sorry, I just got a window that popped up. I was trying to get rid of. I don't know why Zoom's sending it, but anyhow, the Roman numeral, you're not really going to see it for anything other than metal non-metal combination, and so that Roman numeral is to be used with the multivalent metals. But anyhow, it will come in handy for the steps. Okay, so we've identified metal, non-metal. Okay, we write the symbols. Okay, manganese and then sulfur. Write the charges. Here's what's great about the Roman numeral being there. We already know what the Roman numeral is for manganese. We don't have to look it up because there it is. Roman numeral 4, so +4. Okay, so the sulfur, we're going to need to look it up, -2, right? So we cross over. Okay, look at where the numbers now appear. Remove the charge. Simplify 2 to 4 becomes, simplifies to 1 to 2. Remove the 1, and there's the formula. Now, here is something that I want you to make note of. Be careful. If you are being asked to go opposite, so here's what the question will be. Question's going to give you, okay, I'm going to give you this formula here. I'm going to ask you, what's the name? Okay, and so easily, remember how we were looking at it moments ago and we said, oh, where's that 2 come from? That 2 came from manganese. But if you look at manganese, manganese can actually have a +2 charge. So be careful when naming formulas, because one thing to make note of is this. What number was here? This was a, oops. There was a 1 here. If we bring that 1 back to where it is, the oxidation number for sulfur is not a -1. It's a -2, which means something got simplified. You'll see that in a moment if it's not making sense because I'm overlapping it with a question that we've already done right now. But you'll see it in a moment. So anyhow, here's the formula for manganese for sulfide, right? Here it is. Okay. So let's look at these sample problems. And this is the one that, this very first one here, 1A, is the one that gives students problems, because when they look at this part, when they look at this formula, this is what they see. They think, they see this 2 and they go, oh, it's got to be a lead 2 oxide. Remember the non-metal, the IDE ending. These are binary. Right? Remember what we talked about with binary? Up 2 uppercase letters, 2 uppercase letters, 2 uppercase letters, 2 uppercase letters, binary, 2. Anyhow, common mistake, they'll name this lead 2 oxide because they're saying, hey, that 2 is what comes, and you know, this 2 came from lead. Yes, it did come from lead, but it was simplified to become that 2. Okay, let's look at what the answer actually is. In fact, there it is. It's actually a lead 4 oxide because, right, if we go back to looking at that, okay, oops. This 2, yes, this 2 did come from the lead. However, there was a 1 here that we remove, right? Because there's no number now. So it must have been a 1 originally. So that 1 must have come from oxygen. But oxygen, if you look at the periodic table, the oxide oxidation number is a -2, which means it's not -1. So if it's not -1, then it must have been simplified to a -1. Okay. So be careful. You'll find all the answers on the website. Feel free to contact me. I will try to put mini videos of all these lessons and try to organize it now that I've got a little bit more time. I am trying to rebrand my channel a little bit now, especially now that I've got a little bit more time. So you will see in the coming days, coming weeks, that I will be trying to put some more stuff and trying to organize those videos a little bit for you guys and for any of my future students. So please feel free to email me. I will try to keep in touch through my website. I will post on right underneath that message. I'm going to keep that message going and just add to that message anything that I've heard with regards to making sure that this course kind of runs, because technically I'm not getting paid for this part. I don't care, to be honest. My biggest concern is the fact that I've got a class full of students who are hoping to get this credit, and this is one of the reasons why I'm trying to keep this course going. And to be honest, my March break is done, and I'm getting kind of stir crazy not being able to do what I enjoy doing. Okay, so that's one of the reasons why I'm doing this, because it's an opportunity to kind of do what I look forward to doing Monday to Fridays when I'm at school. Let me just, before we move to the next lesson, I do want to kind of look at the questions, the comments here. Thank you. It was very nice of you. Thanks, Tristan. The assignment on Chapter 3, you'll be posting these lessons on the website. I will be posting these on my YouTube channel. So it'll be at Papa Podcasts, and you'll see them, and I'll post it specifically that it's Zoom lesson. So it'll be labeled as a Zoom lesson. So I'll put the title, and that it'll be under a Zoom lesson. Okay. And then I'll have specific lessons based on, so what I want to do, one of the things that you'll notice that if you look at my videos, they're not labeled with the chapter title. Okay, so what I'm going to do now is I'm going to try to have all chapter titles associated with the videos, but I'm going to try to make some new videos and try to break them down into like smaller pieces. Now, with regards to the assignment, we're going to hold off on the assignment due date just because I'm waiting to hear about evaluations. I'm cool with accepting them. If you want to email them to me if they're done, I will not penalize you if it's not done. But if you do want to kind of at least have it out of the way and just email it to me, that'd be great. Otherwise, if you've not done it, if you want to hold off, because like I said, there is a possibility that they can end up scrapping the night school course. Okay. I'm going to do what I can to try to keep it going. And again, there's always going to be people powers that be, greater than like higher out of my pay grade, that could end up saying, sorry, it doesn't matter how you're running the course. It's technically not to be done this way, but I don't know. But like I said, I'm going to do what I can to keep this class going. So in terms of the assignment, if it's done, email it to me. If not, don't worry about it for now. Cover 4C on the assignment. Let me see what 4C on the assignment. Let's see. I don't have the assignment. Okay, let's see what's the 4C assignment. Okay. Yeah, so with regards to the video, I'll have them I'll try to make some smaller videos of all the lessons and all the future stuff that we're going to be covering. So you don't want to read through the slides. You can watch the videos if you like. So let's see. Chapter 3. Okay, 4C, the IBR3. Is that, yeah, okay, the IBR3. Okay, so let's take a break from the nomenclature. Okay, let's share a different slide. Oops, share. So, okay, so IBR3. So we know that iodine will be the central atom. Iodine has 7 valence. 1, 2, 3, 4, 5, 6, 7 valence. Bromine also. So we've got 3 bromines. I'm going to put them both here, but then we're going to clean this up. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, and 1, 2, 3, 4, 5, 6, 7. Okay, so in terms of our bonding sites here for around iodine, we only have 1 bonding site. All right, so which means with that 1 bonding site, this is where it's going to bond. It's going to bond to bromine. But somehow we've got to bond 2 more bromines to it, but they're all full. Understand that iodine appears within or past the 3p block, which means anything in the 3p also contains an empty D subshell. Remember how so anything in the 3p, 4p, 5p, 6p, they all can undergo that expanded octet. Okay, so the expanded octet, which means this pairing here are going to split up. Okay, so let's try to split them up. And form a bond. Okay, so what we're going to do, okay, so what we're going to do now is, let's clean this up because this kind of looks messy. Okay, so what is this going to look like? Well, we've got iodine bonded 3 times. 1, 2, 3 bromines, 1 unshared pair, 2 unshared pairs, right? 1, 2 unshared pairs. So we've got 3 bonded. We've got 2 unshared. Total of 5 regions of high density electrons. Right? Remember what the geometry is, and if you look at really what I used, kind of remember the pentagon shape. Okay, but we're not going to put those yellow lines there. I just wanted to show symmetrically, and what we have here is a T-shaped Vesper drawing. Okay, so hopefully that helped out. Okay, so let's go to our next lesson here. Let's go to polyatomics. Typically, we do a test yeah, at the end of the naming. We're not going to be able to do the test for naming. So with regards to, luckily for you guys, you're not going to have to memorize the polyatomics, but typically I have my students memorize the polyatomics. Okay. So let's look at the polyatomics. So polyatomics consists of two or more non-metals. So remember how we were looking up until now, everything we've been looking at binary. Okay, binary. So meaning two. So remember how we said, you know, a great hint, two uppercase letters. But here now with polyatomic, most, okay, there are a few exceptions, but majority, if not almost all of them, but there are some exceptions, will contain three uppercase letters. Okay, so three uppercase letters. That's your hint that you'll have a polyatomic. But also some of the names that you're going to see will be a hint as to you having a polyatomic. Okay, so here is your list of a bunch of polyatomics. Typically, I don't have you guys memorize all of these polyatomics, but I want you to, so we're not gonna, so I'm gonna go through this lesson a little bit quicker just because there's nothing to really memorize for this course. But what this lesson actually does is actually, it will simplify that memorization. And how that memorization is going to be. So we're going to kind of look, so what this lesson focuses on and is how to remember it without really having to memorize, like somebody would have to memorize a script. Okay. So I didn't come up with this, but I wish this was around when I was a student. But someone had come up with this really cool little phrase called Nick the camel ate a clam for supper in Phoenix. So you're probably looking at that going, how does this relate to chemistry? Well, each one of these 5 words, these 5 keywords, right? Nick, camel, clam, supper, Phoenix, are derivatives to 5 typically used polyatomics that you're going to see in a lot of the sample problems, a lot of the homework, and whatnot. Okay, so the underlined letter represents the element. Okay, so let's actually look at it. So the underlined letter represents the symbol of the element. Okay, so nitrogen, carbon, chlorine, sulfur, phosphorus. The consonants in Nick, camel, clam, supper, Phoenix, okay, represent the number of oxygens in that polyatomic. And the vowels, the number of vowels in each one of these words will tell us the oxidation number, okay, which are all negatives, okay. So let's look at the first one. So Nick, if you break down Nick, right, the underlying letter is N. There are 3 consonants, the N, the C, and the K. So 3 oxygens. There's 1 vowel, so the oxidation number is a -1. And typically nitrogen, okay, would be considered nitride when it's got an oxidation number, when it's got its charge. But this IDE, when you don't see the IDE, remember IDE endings typically are binary. But look at this new ending now, ATE. This ATE ending, and this kind of goes back, okay, to the word ate. Okay, Nick the camel ate a clam, meaning that these polyatomics will have the ATE ending. Okay, so this ATE ending means nitrogen with oxygen. Oops. Let's look at the next one here. Carbon with oxygen. All right, so break down carbonate, and that's the polyatomic. So you're going to have 5 standard polyatomics. Okay, nitrate. Actually, let's get to that slide. Let's. Oops. Let's try to get to where we have it. There we go. So here are the standard polyatomics. Okay, so we've got nitrate. We've got nitrate, nitrogen with oxygen, carbon with oxygen, chlorine with oxygen, sulfur with oxygen, phosphorus with oxygen. Okay, and based on Nick, camel, clam, supper, phoenix. Okay, so these are 5 of the most commonly used polyatomics. Now we have derivatives. Okay, so if you look at this polyatomic, NO4 minus 1 and NO3, we have an increase of 1 oxygen. So nitrate, when we add an oxygen to nitrate formula, we're not doing it like there's no chemical reaction, it's just, it appears. It's just, that's how that formula happens to be, or that polyatomic ion happens to be. So we add a per in front of the polyatomic if each polyatomic has an additional oxygen in comparison to the derivative polyatomic. So the derivative polyatomic is what we get using that Nick, camel, clam, supper, phoenix. If we take away one of those oxygens, okay, so we're going to take away an oxygen. Okay, so NO3 minus 1 becomes NO2 minus 1. So when we remove an oxygen, the polyatomic becomes ite. And then the polyatomic ite ending, notice even these have ite endings. These ite endings mean we've lost an oxygen. Okay, not from a chemical reaction, they just don't have an oxygen. But if we remove a second oxygen, we remove 2 oxygens from all of these, we're going to add a prefix to go with that the ending name change. Okay, so take some time to look at these. Hopefully it'll kind of click and ring a bell. We'll go through some sample problems to see where this all comes from. But I do want to introduce some of the other polyatomics that I typically use in my evaluations. Okay, so let's look at some of the other polyatomics here. Okay, so some other polyatomics that we're going to see, are hydrogen polyatomics. Okay, not as common, but you'll come across them nonetheless. They only work for these 3 polyatomics. The reason why it doesn't work for nitrate and chlorate is because all of them have a -1 charge. Okay, notice here, carbonate, sulfate, and phosphate each have an oxidation number of either a 2, -2, or a -3. When we add an H to those polyatomics, notice how the charge, the oxidation number, drops by 1. Okay, so when we add a hydrogen, we remove a charge from the polyatomic. If we remove the charge, right, from nitrate, we put an H there, we drop that charge, it's no longer an ion. Notice there's no charge anymore. We get rid of that -1, it's gone. Same thing would be with chlorate. But with carbonate, though, when we add an H to it, we still have an ion still left. So we still have a -1 charge left. Okay, let's look at, here are some of the polyatomics. Typically ask my students to memorize, of course, because you will be doing this, any evaluations at home. You'll definitely, be using, I guess, a formula sheet. And so, so in terms of the like I said, so because we're not these are all the only polyatomics to know. So if you want to have a list, maybe print out the polyatomics that I have in these slides. Don't print out the one at the very beginning. Don't print out this one because, well, you can, I guess, but there are many of these that we're not going to. If you want, you can print this out and then look to see which one of these polyatomics you don't see in this lesson. Okay, in 4.3, and just cross them out. Okay, and use that as your, I guess, your cheat sheet when you're doing any of the evaluations, whether it be a test or a quiz or even an assignment. Okay, so let's look at when we're naming them. Okay, so when we're naming, same rules apply. Look for metal, non-metal. Okay, and here we have metal, non-metal, but now notice the ending, the ATE. Notice before we had the IDE ending. Binary, the ATE ending means sulfur with oxygen. So we've got so ferric sulfate. So write the symbol. Okay, so Fe and sulfate SO4. But now make note here, one thing that to know with polyatomics. Polyatomics will have brackets. So you'll put brackets around it because when you put the charge, okay, when you put the charge, you need the brackets because what's going to happen after the charge is the crossing over. When you're crossing over to the outside of the set of brackets. Okay, because you don't want the number outside of the brackets, right? When that crosses over, oops. Let's look at that. So when we bring that over, we don't want those numbers to mix up. So we want to separate them. Okay, because remember one of the steps when in the crossover rule, we want to simplify the numbers and we remove any ones. When we simplify, we do not touch the polyatomic. The polyatomic is as is. Okay. The only thing we simplify in this simplify the numbers to lowest terms is the numbers that we've crossed over. That's it. So if you want, technically, if you want, you can simplify right there, which you can't. Okay, but if you could, that's where you could start your simplification if you wanted to. Let's say but I like to keep all the steps the same, so that when you've got every rule in an evaluation put together, you're not going to be like, okay, am I using this rule of simplifying or that rule of simplifying? So we're keeping it all nice and simple. Okay, so where are we? So remove the charges, simplify, which we can't, and then put the formula together. Here it is, Fe2, open brackets, SO4, close brackets, 3. And there is the formula for ferric sulfate. Another thing to make notice the ferric name. Okay, ferric iron, which iron? The IC ending is for the higher of the two charges. The higher of the two charges, plus 3. Okay. Here's another one, ammonium hydrogen phosphate. So identify metal, non-metal. Here's the trick, though, make note of. Oops. Ammonium is the metal. Okay, it's one of the polyatomics, by the way. So if you're looking at ammonium, understand ammonium is one of the polyatomics on my list of polyatomics. So on that list of polyatomics to memorize, there's ammonium there at the bottom left corner. And notice it's the only polyatomic that actually has a positive charge. Okay. A lot of times students will be looking all over the periodic table for ammonium. It's not going to be on the periodic table since it's a combination of nitrogen and hydrogen. So ammonium hydrogen phosphate, identify metal, non-metal. Okay, now here's a hint. Metal, the rest of this is a nonmetal. Okay, the rest of that is a nonmetal. So let's look at them. So here's ammonium, NH4, hydrogen phosphate, HPO4. Let's put the charges in just because they're polyatomics. Okay, now, if you're trying to figure out this polyatomic, well, remember, PO4 is a -3. Okay, so I remember it. But if you look at the word Phoenix, because that's that Nick the Camel ate a clam for supper in Phoenix. I do have videos for these polyatomics to help you memorize these polyatomics. So if you want, feel free to look at them. They are one of my more popular videos on YouTube, just because it's that Nick the Camel is just it's a great tool to help you remember the polyatomics. But anyhow, so phosphate is derived this is the formula for phosphate, PO4 -3. But we don't have a phosphate only. We have a hydrogen phosphate. So if you add an H to that polyatomic, that charge drops from -3 to a -2. Okay, so there you have it, right? So if you're trying to figure out, I guess, some little hints to remembering these polyatomics, there it is. When we're crossing over, remember, we're crossing over to the outside of the brackets. So we put brackets around. We put charges to the outside of the brackets. Okay, we cross over, -2, +1. Remove the charge. Okay, so remove the charge. Remember, the simplifying is only between that 2 and the 1 that we crossed over. Okay, so what we do, we remove the 1, and in fact, we could even remove the brackets only on one of them because it was just a 1. Okay, so notice here, because we have a 1 outside of the brackets, we could actually remove the bracket. Okay, at the end, when we're naming it. If you want, you could have just left it. I'm not going to be picky. If you just answered it as such, okay, and you kept the brackets, that's fine. But if you're wondering why I removed the brackets, because technically, if there is a 1 outside of the brackets, okay, I repeat, if there is a 1 outside of the brackets after you've crossed over, you can remove the brackets from the polyatomic. Keep it safe for yourself. Keep the brackets always. Okay, this way, you know, you're not going to worry about, oh, do I remove them now or not? Okay. That polyatomic variation that we were talking about, this is what we mean. Okay, so the ending, the ATE ending, is for that Nick, Camel, Clam, Supper, Phoenix. If I add an oxygen to all of those formulas, we add per to that polyatomic name. If we remove an oxygen from the derivative, from the standard polyatomics, the ending is no longer ATE, but it becomes ITE. If we remove 2 oxygens, that IT ending still remains, but now we add a hypo to distinguish between losing 1 oxygen and losing 2 oxygens from the polyatomic. The other thing to make note of, remember when we were adding hydrogen to the polyatomic, that a charge got removed? When we remove, okay, when we remove an oxygen or add an oxygen to the polyatomic, notice the charge, the oxidation number, are the exact same oxidation numbers for all of them. So all the nitrate ones, they're all the same. All the carbon ones are all the same. All the chlorine ones, all the same. The charge does not change. Okay, so notice that, right? So all the charges for carbonate, regardless of whether we lose one oxygen or lose 2, excuse me, the charge does not change. Okay, I've got some sample problems here. Practice them. A great way to what do you call it? To really get accustomed to naming. If you look also on my website, let me share podcast replay. Is it not going to let me? It's not letting me load my website. Well, anyhow, I don't know why it's not letting me show my website. If you go to my website, the popuppodcast.weebly.com, in the main, on the main page, when you see all the different boxes to link, you will see that I have a Quizlet section. I recommend using the Quizlet section if you want some practice when it comes to the nomenclature. Great tool. I've got like about 117 questions, and you can just kind of go through. It's a flashcard style. You could either join my class, or set up an account, or just use it as is without setting up an account. It doesn't make any difference. It allows you to kind of play around with the naming and giving yourself some practice with the naming. Okay. What we're going to do now is I'm going to stop there. So next class on Wednesday, we are going to address the remaining of the naming, and we'll see about trying to start balancing equations. Okay, so in the meantime, look up the rest of the nomenclature, look up these nomenclature, and get accustomed to what we've kind of covered, so that this way you can kind of fine tune, maybe try to allow you guys to be a little more interactive with regards to asking, let's say, your questions. So please do go through those lessons in preparation for Wednesdays. So again, Wednesday, 6:30, we're going to meet up. Again, if you know anyone else from the class who want to kind of join us, let them know to come online. Okay. I will leave this last little bit. If anybody has any questions before we wrap up for the evening. Is everyone okay? Hopefully you guys are all okay. I hope you guys are practicing your social distancing. If you don't understand what social distancing, you're not getting together. You're not hanging out with anybody. You're staying home. Okay, you're going out if you gotta do grocery shopping. So I do want to address what's going on, and hopefully you guys are aware, but apparently there's people that don't really know, because when I do go out for walks, although I'm very apprehensive when I see people coming anywhere near me, like even when they're walking, like I will go in an opposite direction. I treat everybody almost like they're zombies. Not because I'm paranoid, but that's the whole point of social distancing. Staying away. I really don't know whatever anyone has. If you look up some of the real statistics from real healthcare experts, the coronavirus symptoms don't appear for anywhere from 2 to 10 days, I think, 2 or up to 14 days. Anyways, that's why they're saying, if you're coming from vacation, from traveling from somewhere, that you self-isolate for 14 days. So if you know anyone who's kind of come back, tell them stay home, right? Find someone, or tell them if they need groceries because their refrigerator is empty, tell them to find a way to get the groceries delivered to them. Get food delivered to you. I know Uber Eats has that door.
where they will drop it off at your door, so you're not coming into contact with anyone. Okay, so please do practice, do your part to help flatten the curve. With regards to flattening the curve, um, yeah, we could kind of, the sooner we actually kind of, um, I guess, practice our social distancing, we stay home here. You got an opportunity to stay home, do nothing, okay, or find something to do, I guess. Keep yourself busy, read something, go online, um, you know, just do something, stay home. You're not getting together with family members. I've not been able to visit my parents. I do talk to them, reach out, talk to someone. You want to send me an email, we can email. We can chat this way if you want. Like, just get get accustomed to the way things are right now. Try not to panic. I'm not really, I don't really worry too much about it. Like, I do worry about it with regards to, yeah, if I see somebody out and about, and you don't want to be anywhere near, because that's the whole point of social distancing. But get out, get some fresh air, go for a jog. But again, you're not getting together with friends. Okay, you're not getting together with friends at the park. You're not getting together at a park. Just talk to them on the phone, chat with them online in some way, shape, or form. FaceTime. My daughter's been FaceTiming with her friends from school. So, I text message a bunch of my friends just to see how it's doing. Reach out to someone, but you're not getting together to meet up with them. Don't be fools like some of the ones that I've come across online. People partying, beaches, Florida, not practicing their social distancing. People who've come back from vacation, the so-called Canadian snowbirds. So older people who are staying in Florida during the winter time, and then they come back in the springtime. They're coming back from Florida now, and they're going straight to the grocery stores. So that's not helping us kind of contain this virus. So we've got to do our part, okay? But at the same time, just try not to panic. Just kind of go about your typical day to day, but just do it indoors. Find things to do. Okay. It's been tough, yeah, but hey, I'm getting an opportunity to kind of just stay home and really do not much. Yeah, I'm getting a little stir crazy. I've been sitting on my computer the last couple of days doing a bunch of schoolwork, and just kind of getting stuff ready for my classes, and not knowing, like, no one's told me what I've got to do. I just kind of took it upon myself to do this for my students. And I'm going to continue to reach out to my other classes, my day school classes, any way I can, just because, hey, you know what? Let's make the most of this situation. Yeah, this situation sucks, but there's a bunch of us. We're all going through this, so we're all going through this together. So, really don't, try not to let it worry you. If you've got family who's older, you'd like to visit. I love to visit my grandmother. I've got to talk to her on the phone. She doesn't quite understand. I'm like, listen, I can't, because I don't want to take a chance, because I've been fine. I haven't shown any symptoms, but I've only been away from, I guess, exposure the Friday just before March break. So it's been quite a few days. Saturday, Sunday, yeah. So so we've almost been, about this is day 10, I think, that I've not been around anyone. So still, technically, symptoms could still show up if I was, but I'm not. I'm assuming I'm not. We'll see in a couple of days, but yeah, I'm avoiding doing anything else. Okay, so please do your part as well. Okay, and try not to panic. Don't worry. If you are getting some anxiety issues, want to drop me an email. We'll chat about it. I'll do whatever I can to kind of help the course, as well as any of the mental health issues with any of my students who want to just kind of reach out and just talk to someone. Okay, so don't be shy to drop me a line. Okay, have yourselves a wonderful evening, and I will see you all 6:30 on Wednesday. Take care.